So today we're going to start chapter 9, section 1, and we're going to learn how to solve system of equations. So today really what we're going to focus on is solving a system using substitution. There are actually 3 methods of solving systems. In Algebra 1, they teach you the long way first. They make you graph. Then they teach you substitution. Then they teach you elimination. Our book is a little backwards. We're going to do substitution first. Then in 9.2, we're going to graph and do elimination. However, sometimes when you're given these questions, they're set up better to use one method over another. The problem with graphing is if you're not doing it on graph paper or on a grid and you're not making your lines precise, you can miss the point of intersection. So in the first night's homework, we're going to only be working on linear systems. So when we have a linear system, we can either have one solution because our 2 lines are going to intersect, and the solution is going to be that ordered pair, that XY, where the 2 lines cross. Or it could have no solution because the lines are parallel. So this would be a no solution scenario. We did this in geometry as well. This would be the one solution answer when the 2 lines intersect. Or if once you rearrange them into y equals mx plus b form and graph them, let's say the first graph was this line, and then the second graph, let's say it turns into the identical line. When it's the same line or same equation, this is the scenario of infinitely many solutions because it's exactly the same line. So in addition to linear, we're also going to be coming up at the end of the notes maybe being given an equation for a parabola, and the other equation could be a line. So in this scenario, we would have 2 solutions. Or just like before with the parallel lines, let's say our parabola was graphed up here, and then the line was down here. And this would be no solution. Or let's say we graph the parabola, and let's say the line skims along the bottom and only touches the parabola at the vertex, and that would have 1 solution. We'll also see some equations of ellipses, and maybe you'll have one going this way, one going this way, and this would have 4 points of intersection. So all different scenarios for these systems. But today what we're going to focus on are the linear systems. So 2 straight lines. So let's take a look at example 1. Now the instructions say to use substitution. But honestly, this one is really set up better to do elimination. But I'm going to go ahead and show you substitution. So what you want to do when you're using the method of substitution is you're going to take one of the equations and solve it for either x or y. And in this case, always look for one of the variables that doesn't have a number in front. And then that way you're not going to get any fractions. So what I'm going to do is I'm going to take this second equation and I'm going to actually put it into y equals mx plus b form. I'm going to solve it for y. So I'm going to take x minus y equals 2. And I'm going to subtract the x. I could have also solved it for x. It really doesn't matter. And then I don't want a negative y, so I'm going to divide everything by -1. And now my equation is y equals mx plus b. I could actually do that with the other one and then just set them equal to each other. But instead, what I'm going to do is now I can't take the equation that I just rearranged. I now need to take the other one. So the x plus y equals 4. And now what I'm going to do is I'm going to take out this y and I'm going to put what y equals. So I'm going to erase this and then I put x minus 2 and then I'm going to rewrite the rest of the problem. And now I combine like terms. 1x plus 1x is 2x minus 2 equals 4. Add 2. 2x equals 6. Divide by 2. And x equals 3. Now remember, the solution for these systems is an order pair. I now need to take my newly found value of x and I need to plug it back in. And I can plug it either back into my rearranged equation or one of the originals. It really doesn't matter. Honestly, the rearranged one would be the fastest. So if I just take this and plug in a 3 for x, I get y equals 1. So the solution to this system is the ordered pair 3, 1. One way that you can check your answer to see if it works is take both equations, the x plus y equals 4 and the x minus y equals 2. This is x, this is y. Plug it in. So 3 plus 1, does it equal 4? Yes, it does. It works in that one. And then if I do the same thing here, 3 minus 1 equals 2. 2 equals 2. It works in both. So the order pair 3, 1 is a good solution. Now you could have also rearranged them. What we're going to do in section 9.2 is we would graph both of these equations and then find the point where the two lines intersect. Now honestly, this system is probably faster to solve using elimination. Because when we do elimination, let me just rewrite it, is I add the two equations together. So notice when I add these two together, the y's cancel. And then I add 1x plus 1x is 2x. 4 plus 2 is 6. Divide by 2. And x equals 3. I find y the same way. I plug this x value in to one of the originals. Okay, so for number 2, again, the instructions here officially say to use substitution. Because again, in 9.2, we'll do the elimination method and the graphing method. So I'm going to go ahead and solve my first equation, and you can choose which equation you want to solve for either x or y. I always look for a variable that has a 1 in front. So what I'm going to do is I'm going to go ahead and solve it for x. So I'm going to take my first equation, and I'm going to move and isolate x by adding y to both sides. And now I'm just left with x equals y. So this is a clue that when I'm all done, whatever value of x I get, it's going to be the same for y, because x and y are going to be equal. But I'm going to go ahead and do the whole solving process. Now, once you rearrange one of the equations, you must substitute into the other equation. So now what I'm going to do is I'm going to take my second equation, the 5x minus 3y equals 6. So because I solved for x, I'm going to take what x equals, which is y, and replace x with what it equals, which is y. So now I'm going to do 5y minus 3y equals 6. And now add my like terms. 2y equals 6. Divide by 2. And y equals 3. Now, you don't necessarily always have to solve for x first or y. Just be nice and neat when you're solving this so you remember what you're solving for first. So far, out of my solution, I've gotten the y value. And now to get my x value, I've got to plug it back in. Now, I'm going to go ahead and notice if I plug it into the one that I rearranged, if I take x and then replace what x equals, which is y, and y is 3, x is also 3. I could have also plugged it in to either of the originals. It really doesn't matter. So like if I would have taken my original, x minus y equals 0, and plug in y equals 3, and then solve it this way, it doesn't matter. You're getting the same answer either way. And again, this solution is an ordered pair. It's the point of intersection where these two lines intersect. And again, remember, you can plug this ordered pair back in to your original equation, and if it doesn't work for both, then you've done something wrong, and I highly recommend you go back and start all over again. Because what the problem with this is one little sign mistake and it messes everything up. So what I mean by doing the check is if you take this ordered pair 3, 3, and then plug it into the first equation, I plug in 3 for x, 3 for y, 3 minus 3 is 0, it works for that one. And then if I take my second equation, and again, plug in 3 for both x and y, and then follow my order of operations, multiply, and then subtract, I did get 6 equals 6. So the ordered pair 3, 3 is the solution for that system. When you go to take an SAT or an ACT, again, they love system of equation questions. Sometimes they'll just ask you what would be the two equations that you would use to solve the system. And maybe they don't even ask you to solve it. And then other times they may ask you to solve part of it or even find the ordered pair. So what I'm going to do first is I'm going to define what my x equals and what my y equals. I'm going to define my variables. So what I'm going to do is I'm going to let x equal the amount of money that I'm going to invest in the 5% fund. And then the y in my equation is going to be the amount of money in my 3% fund. So what I'm going to be doing is writing two equations, one for the amount of money that's being invested, and then the other equation will involve these interest rates and the amount of interest. So when I go to set it up, it's telling me that a total of $12,000 is invested in two funds paying 5% and 3% simple interest. The total amount of annual interest is $500. How much is invested in each rate? So again, I'm finding the value of x and of y. So my first equation is going to be concerning the amount of money that's invested. So I know I invested some amount in the 5% fund and some amount in the 3%, and together they add up to be $12,000. Then my second equation is going to involve the interest. And I'm going to make those percents into decimals. And what I'm going to do is use 0.5 times x. That was what I had established as my 5% fund. And actually, sorry, it should be 0.0. Let me fix that. 0.05x. Because when you convert a percent to a decimal, I take away the percent sign and move it 2 times, or divide it by 100. And then now for the y, that's the 3%, so 0.03y, but that interest amount was $500. So now I've got my system. Now I can choose a method to solve this. Because 9-1 is supposed to be substitution, I'm going to use substitution. However, I'm going to use a trick that I taught you at the beginning of the school year, and I'm going to clear the decimal. I'm going to multiply that second equation by 100, or essentially move all the decimal points 2 times to the right. And then it'll be a little bit simpler because you're not using a calculator. So I'm going to go ahead and multiply this by 100, which will move the decimal point, and put this back as a 5x plus 3y. And I also have to move the decimal point 2 times on the 500, making it 50,000. Now what I'm going to do is I am going to rearrange and solve my first equation, and I'm going to solve it for x. And then that's what I'm going to substitute. Again, always try to solve or rearrange equation for either the x or the y that doesn't have a coefficient in front. So like it's got a 1 in front. So I'm going to take my first equation, my x plus y equals 12,000, and I'm going to solve it for x. So I'm going to subtract y from both sides. And now the expression that I have for x is 12,000 minus y. This is what I'm going to substitute in for the x value in my second equation. And I have to distribute 5 to that expression. So I'm going to put it in as a parentheses. So I'm going to do 5 times the expression for x, which is the 12,000 minus y, and then rewrite the rest of the equation. And now I'm going to distribute. 5 times 12,000 is 60,000. And then 5 times negative y is negative 5y. And then drop down the rest of the equation. I'm going to combine my like terms. So I have the negative 5y plus 3y. I'm going to rewrite everything. 60,000 minus 2y equals 50,000. And now my goal is to solve for y. So I'm going to subtract 60,000 from both sides. And I get negative 2y is equal to negative 10,000. Divide by negative 2. And negative 10,000 divided by negative 2 gives me positive 5,000. So $5,000 was invested at the 3% fund. So 5,000 at 3%. And now I need to find the amount invested at the 5%. And again, I could either go back to one of my two originals, but honestly, what'll be the fastest one to plug it into is the rearranged. Or again, just subtract 12,000 minus 5,000 is what I'm doing. So 12,000 minus what I just calculated for y, which is 5,000. So the amount that was invested at the 5% is $7,000. Sometimes on an SAT, again, they might have just asked for the two equations. Or maybe because they know that your time is limited, they might have just said how much was invested at 5% or how much was invested at 3%, and maybe not ask for both. Okay, so for number 4, I'm going to do exactly the same thing. Let me come over here to the side. I'm going to define my variables. So x is going to be the amount that's invested at the 6.5%, and y will be the 8.5. Now, it doesn't matter which one you declare as being x or y. Just remember what you do when you put it into the two equations. So again, one equation for the amount of money invested. So the amount at the 6.5% plus the amount of money at the 8.5%, and that total amount of money that was invested was 25,000. Then my second equation will involve those percentages, and again, I'm going to make them into decimals. So my 6.5% goes with the x, so 0.065x plus 0.085y. And this time, the interest amount was $2,000. I can do exactly the same thing, and I could clear the decimal point. Notice this time I've got 3 numbers behind the decimal point. So either think of it as multiplying by 1,000 or just moving the decimal point 3 times. So then this would now give me 65x plus 85y is equal to 2 million. Now, let's say I wanted to do the elimination method. I could still go back and do the same thing that I did on number 3. Now, if I do the elimination method, I'm going to take my other equation, and you always want to line it all up. Put the x's on top of each other and the constants and the y's. For the elimination method, what we need to do is make either the x's or the y's to have the same number in front, but one negative, one positive. So what I'm going to do by using my elimination method is I am going to multiply my second equation by negative 65. And then that's going to get my equation to cancel the x's. Now again, you could do substitution on this. I just want to show you have options. So once I distribute negative 65 to all 3 terms, I end up with negative 65x minus 65y, and then I have to multiply 25,000 by negative 65, and I get negative 1,625,000. What I'm going to do is take this equation and line it up. So I'm going to put it underneath. So then I can add the 2 equations together. So 65, 85y, and then the 2 million. So now I'm going to go ahead and add the 2 together. Notice the 65x's cancel out. And then I do negative 65y plus 85y, and I get 20y. And then 2 million minus 1,625,000 gives me 375,000. Divide that by 20. And y is equal to 18,750. Remember, we define y as being the amount of money that was invested at the 8.5%. And now to find the money invested at the 6.5, I could plug it in to my first equation, x plus y equals 25,000. So x plus 18,750 equals 25,000. And now subtract. And x is equal to $6,250, which is the amount that was invested at 6.5%. You would do substitution method like I did in number 3, or you could use the elimination method like I did for number 4. Generally on an SAT, they're not going to specify what method to use when solving the word problems. Now, they may ask on an SAT, what would have been, like if it was a simple system, they might say, what would you substitute in to solve using substitution, something like that. So now for the nonlinear systems. So these are going to be systems with exponents. So I could either have no solution or I can have more than one solution. So depending on the type of nonlinear system I have, whether it's a parabola and a circle or a parabola and ellipse or 2 ellipses, it could have more than one solution. So let's try some examples. So here is my first example. I've got my first equation that has an exponent in it, and then the second one is linear. Now what I'm going to do is whenever one of my equations in my system is linear, generally that's going to be the one that I rearrange and solve for either x or y, and then that would be the expression that I substitute. So I'm going to go ahead and solve my second equation for y, because notice my coefficient in y in front of y is a -1, but I'm gonna go ahead and solve it so that I can isolate y. So I'm gonna take 2x minus y equals -1. I'm gonna subtract 2x from both sides. Essentially what I'm doing here is putting it into y equals mx plus b form. And then I can't have a negative y, so I'm gonna divide everything by -1, and I get y equals 2x plus 1. This is going to be the expression that I substitute in for y into my other equation. I can never substitute back in to the equation I rearranged. So now let me take my first equation, 3x squared plus 4x minus y equals 7. So what I'm doing here is I'm going to take out the y and replace it with that expression. Now when I replace it, I'm going to put it in with parentheses because I need to remember to distribute the subtraction sign to both terms. So I'm going to rewrite the 3x squared, the 4x, the subtraction sign. Now I'm going to show the expression that I'm replacing for y. And now before I begin to combine like terms, I need to distribute the subtraction sign. So this becomes a -2x minus 1. And then rewrite everything else. And now begin to combine your like terms and set your equation equal to 0. So I can combine my two x terms here in the middle. This becomes 3x squared plus 2x minus 1 equals 7. Oh, that should be a 1. I now need to subtract 7. I need to set my equation equal to 0. So 3x squared plus 2x minus 8 equals 0. I now need to factor this trinomial to get my two values of x. Now, you could technically also use quadratic formula if you would prefer to get your two x values. I'm going to factor. Factor's usually faster. Now, if you're good with guessing and testing, you can. If not, factor by grouping. So let me go up to the top here, and let me just factor it up here. So 3x squared plus 2x minus 8. So I'm going to go ahead and multiply the beginning and the end. I'm looking for two numbers that multiply to give me -24, but add to give me the middle. So rewrite the first term. I'm going to figure out those two numbers. Those two numbers are going to be -4 and +6. So you can replace those numbers in here. It doesn't matter the order you put them in. I'll put the -4 first and then the +6. I'm going to make my groups. I'm going to factor out a GCF here of my purple group, and it's just going to be an x. Divide. GCF of the blue group is going to be 2. Divide. And then put those two together. I get x plus 2, and then the 1 in common. So those are my two binomials. So let me come down here now. You could have also guessed and tested whatever you're more comfortable doing. And then plus 2 equals 0. I now need to set each one of these binomials equal to 0 because I'm trying to find the x value. So I'll go ahead and add 4. 3x equals 4. Divide by 3. X equals 4/3. That's my first x value. And x equals -2. Now, what I need to do is I need to find the y for each of these x values. So now what I need to do is plug it back into one of the beginning problems. So for me, the easiest one to plug into is going to be the linear. And I can use this rearranged one. So once you get your first value of your first either x or y value, you're now going to go back and either plug it in to this one, the rearranged, or one of the originals. It's up to you. For me, the rearranged will be the least amount of work. So I'm going to take my y equals 2x plus 1, and I'm going to plug in 4/3. So 2 times 4/3 plus 1, and this is going to give me 8/3 plus 1. WebAssign wants fractions, not decimals. So when you get any fraction answers, they want the fractions. I'm going to change my whole number 1 into 3/3. So my y value is going to become 11/3. So my first solution is the ordered pair 4/3 and 11/3. And now let's plug in, same equation, y equals 2x plus 1. This time I'm going to plug in -2. So y equals 2 times -2 plus 1. 2 times -2 is -4, and -4 plus 1 is 3. So this order pair is the order pair -2, -3. And my negative sign blended here. Let me fix that. So that's a negative sign there. Let me just rewrite it. -3. So -2, -3. So the two solutions for the two equations is going to be two order pairs. When you're doing the homework, what WebAssign wants is only the real solutions. So after you do these questions, if you get any imaginary solutions, don't include those. But if on an SAT, they say give all solutions, then you'd have to list the imaginary solutions as well. So let's try number 6. When we get to number 7, we'll have an imaginary solution for number 7. All right, so again, I'm using substitution. So if I have something linear and it doesn't have a coefficient in front of the variable, that's what I'm going to solve for. So I'm going to take my first equation, the -2x plus y equals 5. I'm going to solve it for y. And all I have to do is add 2x to both sides. And I get y is equal to 2x plus 5. I'm now going to take what y equals and plug it in to my second equation where I see the y. So I'm going to rewrite the x squared, the subtraction sign, but I'm going to put what y equals in parentheses so I remember to distribute that subtraction sign. And now I'm going to distribute the subtraction sign and combine like terms. So I'll distribute this, and this becomes x squared minus 2x minus 5 plus 3x equals 1. I now need to set my equation equal to 0 and combine like terms. So I have a -2x and a positive 3x that I can combine. So that gives me x squared plus x minus 5 equals 1. I need to move the 1 over. And I get x squared plus x minus 6 equals 0. Now at this point, you can either choose to use quadratic formula or factor it. This one's nice and easy enough to factor. The factors of -6 that give me positive 1, those are going to be the factors of positive 3 and -2. So my factors are going to be x plus 3, x minus 2. I now need to take those two binomials and set them equal to 0. So let me come on over here to the side. So I'm going to take x plus 3 set it equal to 0, and x minus 2, and set it equal to 0. This is going to give me my two x values of my two ordered pairs. But then I have to take each of these x values and plug them back in to either one of the original equations or my rearranged. And I'm going to use my rearranged because, again, I've already got what y is all by itself. So I'm going to take y equals 2x plus 5, and I'm going to use it twice, one for each of the x values I just found. So I'll do it for this one first. First, plug in -3. So y equals 2 times -3 plus 5, which gives me -6 plus 5, and I get y equals -1. So my first order pair is -3, -1. I'm going to do it again, but this time plug in +2 for x. So y equals 2 times 2 plus 5. 2 times 2 is 4, and then plus 5, and I get 9. So then that order pair is 2, 9. So my two solutions for this system are going to be the order pair -3, -1, and +2, +9. When we do the next one, it will have an imaginary solution. WebAssign only wants real solutions. So if you get anything that is imaginary, you're going to say it's no solution. However, on an SAT, they may ask for all solutions, and then you would have to include the imaginary. So let's go ahead and try number 7. So here are my two equations. This is my system. Again, I'm going to take the linear equation, the first one, and I'm going to solve it for y. You could also have solved it for x. It really doesn't matter. So I'm going to go ahead and essentially put it into y equals mx plus b form by adding the x to the other side. And I get y is equal to x plus 4. This is what I'm going to substitute in for this y value here. Now, if I would have solved it for x, notice the x squared is positive. Then I would have had to take that binomial and FOIL it. And it would have gotten a lot more complicated. So this is why it was easier to solve for y, because y didn't have an exponent that I needed to apply to it. So let's go ahead and rewrite that second equation. So it's x squared plus y equals 3. And again, I'm taking out y and replacing y with an x plus 4. So I get x squared plus x plus 4 equals 3. I really didn't need to put it in with parentheses because it's a positive sign. It's a plus sign. So then I get x squared. So then let me go ahead and let me just drop the parentheses. Then I need to move the 3 to the other side. And I get x squared plus x plus 1 equals 0. Now, if you look at this and you think, what are factors of 1 that give me 1? There aren't any. I can't factor this. It's not factorable. So this is where I would have to do the quadratic formula. And if you've forgotten the quadratic formula, that was that x is equal to negative b, or opposite of b, plus or minus b squared minus 4 times a times c, all under the radical, divided by 2 times a. Now, anytime that this number under the radical, once you plug in your numbers, as soon as this becomes a negative number, that's a clue that you're going to have an imaginary solution. And if that's the case in WebAssign, you can stop because we don't want any imaginary solutions, and you would say no solution. So let's go ahead and plug that in. I'm going to get my A value, which is 1, my B value, which is 1, and my C value, which is 1. And now I'm going to plug them all in. So opposite of B, plus or minus B squared minus 4 times A times C, and that's all under the radical, over 2 times A. And this is what my X is going to be. So X is equal to -1 plus or minus 1 squared is 1, and then -4 times 1 is -4 over 2 times 1, which is 2. And then now once I combine what's underneath my radical, 1 minus 4 is -3 over 2. And again, as soon as you see this in the WebAssign homework that this is negative, know that you could stop and say no solution. However, I'm going to go ahead and finish this just to show you what an SAT would look for. So if I simplify that, my X values are going to be -1 plus or minus I root 3 over 2. Now, I would have to pull this apart, and this would be -1 minus I root 3 over 2, and then my other X value would be -1 plus I root 3 over 2. I need to get the corresponding Y value. So let's take my rearranged equation, which was the Y equals X plus 4. So if I take my rearranged equation and plug this in for X both times, I would get Y is equal to -1. And what I'm going to do is I'm going to pull this apart and make it -1/2 minus I root 3 over 2 plus 4. So that's just that one. Notice I can combine these two like terms. So then this would give me Y is equal to 3.5, or I'll make it 7 over 2, minus I root 3 over 2. That's the Y value. So the order pair on an SAT would be -1/2 minus I root 3 over 2, comma, 7 over 2 minus I root 3 over 2. This would be an imaginary order pair. Again, I will not expect you to do this on the test. Now, I also have to do it for the positive I root 3. So Y equals -1, and I'm going to make it separated. So plus I root 3 over 2. I'm just pulling this apart and giving both pieces its own denominator of 2. So that way when I go to combine these like terms here, it makes it a little bit easier. So the same thing's going to happen here. I'm going to get -1/2 plus 4 is 3.5, which is 7 over 2. So 7 over 2 plus I root 3 over 2. So essentially it's the same thing. The signs are just different. So then the other order pair, same X value, but with a plus sign. And let me go ahead and pull it apart. You could leave it like that or pull it apart like I did here. And then here, the Y value is 7 over 2 plus I radical 3 over 2. And if you wanted to combine it, 7 plus I radical 3 over 2, and then it would look like the same thing here. Or pull it apart and give each one its own denominator of 2. This is what an SAT would look like. So these would be the two solutions if it said to give all solutions. But for WebAssign, soon as you get an imaginary solution, you're going to say no solution. Same thing's going to happen on number 8. Let me go ahead and get that one done. So for number 8, let me rewrite the problem here. So for number 8, I have 2x minus y equals negative 3. And then the other one was the 2x squared plus 4x minus y squared equals 0. So on this one, I think it's going to be easier to solve for the y. So I'm going to go ahead and subtract the 2x, negative y, negative 2x minus 3. Divide everything by negative 1. Y equals 2x plus 3. Now, when I go to plug this in, I'm going to be replacing the y with this binomial, and I'm going to have to FOIL it. So I'm going to get 2x squared plus 4x, the minus sign, and then I'm going to put 2x plus 3, square it, and then equal 0. So I am going to FOIL this binomial. And once I do that, I'm going to get 4x squared, so this is going to be this thing's FOILed, minus 12x minus 9. And I'm going to rewrite the rest of the problem. Next, I have to distribute the subtraction sign. Actually, these are all plus signs. Now I'll distribute the subtraction sign. So 2x squared plus 4x minus 4x squared minus 12x minus 9 equals 0. Combine your like terms. So these two together and then these two. And this gives me negative 2x squared minus 8x minus 9 equals 0. I'm going to go ahead and divide everything by a negative 1 to see if I could factor it. So then this becomes 2x squared plus 8x plus 9 equals 0. So if I were to multiply 2 and 9, factors of 18, that would give me 8. There aren't any. So quadratic formula. So my A is 2, my B is 8, my C is 9. And I'm going to plug it in. Opposite of B, plus or minus B squared, 4AC, all divided by 2 times A. X is equal to negative 8 plus or minus 64 minus 72 over 4. X is equal to negative 8 plus or minus. Okay, then I get negative 8 over 2. I would simplify this, and I would get negative 8 plus or minus 2i radical 2 over 2. I can divide all of these by 2, and then I get negative 4 plus or minus I radical 2 over 2. Again, you would stop, WebAssign, no solution, but if it were an SAT, we would keep going. This is over 4, and then simplify it. Okay, so the denominator here is a 4. But then when I simplify, I can divide all these by 2's. So then this becomes a 1, this becomes a 4, and this becomes a 2. And then you can see that it's got an imaginary solution. So for WebAssign, there are no real solutions. So this one has no real solutions, but if it were an SAT asking for all solutions, then you'd have to keep going and plug in these imaginary X values to get the corresponding Y values. Try number 8.